We have a small program on this slide which seems innocent enough. It reads some integers from the keyboard and then it proceeds to divide the first by the second. The problem, of course, is you can't always do that because if the second number is 0, you can't divide by it. There is no checks and balances in this program to account for that. So if the second number entered is 0, the program will go ahead and attempt to divide by 0, and since that's impossible, a runtime error will occur. Since we haven't dealt with it in an elegant way, it will just cause the program to crash ungracefully. That's probably not the best thing to happen, and we're going to use this as a starting point to see what we can do instead of this to deal with that situation in a better way. This example is an attempt to deal with the problem presented on the previous slide in a more elegant way. Here we've provided a new class called QuotientWithMethod, and what this does, instead of just blindly dividing number 1 by number 2, it checks with an if statement first to see if this can actually be done. In other words, it checks to make sure that number 2 is not 0. The if statement says if number 2 is 0, then I know I can't do this. So what I'm going to do instead of blindly dividing is I'm going to throw an exception. So we do this by saying throw, and then we produce an exception object by saying new arithmetic exception, and then as an argument for its constructor we give a string where the string says divisor cannot be 0. So now, as long as number 2 isn't 0, we will skip that if statement and instead we will simply return to our caller the value of number 1 divided by number 2, which we know we can safely do in this instance where number 2 is not 0. However, if number 2 ever is 0, then instead of going ahead and returning the result of blindly dividing number 1 by number 2, instead we will throw this exception, and as a result the program will stop and it won't wind up dividing by 0. What we did in the previous slide is an improvement over what was in the slide before that. In the first slide we just blindly divided, not worrying about whether or not it was 0 and knowing that we could generate a major error by doing that. In the previous slide what we did instead was that we at least checked to see if it was okay before proceeding and dividing by 0. It's not quite the best we could do, and in fact a great improvement on that is what we see in this slide when we use the existing special mechanism in Java that deals with exceptions. This is called a try-catch block. You'll notice that the code in the middle of the slide has try, opening curly bracket, and then there's a little block of code followed by a closing curly bracket. That's the try block that you see there. Immediate below that is the catch block. It begins with catch, and then as an argument it has a particular exception. And then we have a curly bracket to denote a block of code called the catch block, closed by a closing curly bracket ultimately. The notion behind using a try-catch block is that you try to do what would be the normal course of events, and if a problem occurs, if something happens that prevents that from proceeding, then an exception is thrown and the catch block will catch the thrown exception. Whenever an exception is thrown inside of a try block, you immediately abort the rest of the try block. You stop the try block, you do not go on, and you jump to the catch block that's associated with it. And at the end of the catch block, you're done. You don't go back to the try block or do anything else because you tried and failed in a sense, and the failure is catching the exception and dealing with it instead of blindly continuing on within the try block. When the catch block executes, it will deal with whatever unusual circumstances, whatever exceptional circumstances happened, and then at the end of it, it just falls through and continues on with the rest of the program. So the normal course of events here would be you do the try block, you skip the catch block because nothing goes wrong, and then you find yourself at the bottom of the code that's on this slide where it says system out println execution continues. The unusual event would be that an exception happens, in which case you're in the try block and that's where the exception occurs, and after the exception occurs you abort the rest of the try block and go on to the catch block, and you do whatever's in the catch block, and at the end of that you fall through with whatever code follows the catch block. Whenever you see a try block, you know there's a potential in there for an exception to get thrown. Let's think about the try block that you see here and try to identify where the exception will be thrown, if and when exceptions occur. It's in the first line where we call the quotient method, because if you recall, what we wrote in the quotient method was code that potentially could throw an exception. It actually checked number 2 out to make sure number 2 wasn't 0 before dividing, and if number 2 was 0, then it went ahead and threw an exception. So again, whenever you see a try block, you know that somewhere in that try block an exception could be thrown. It won't always be thrown, because the normal course of events is that exception doesn't occur. But somewhere in that try block there will be a place where an exception might occur, and if it does, and in this case it's the first line of code, then you will abort the rest of the code, so you'll never do the system out print line part of the try block. Instead, you'll abort it and go on to the catch to catch the exception. You'll notice the catch block is very specific. It has an argument that says arithmetic exception, and in case we want to refer to that particular object, we can give it a name, x, ex, that you see there. So the type of object that's passed to the catch block is going to be an arithmetic exception, but it's called ex. That's its name within the block. You can see we don't use ex anywhere in the block, but in cases where we did want to, it would be available for us to use. In this block, we see an example of a generic try-catch block, or a template that you can use. And it's actually try-throw-catch. The throw is going to be initiated inside of the try block. It might not be within the try block itself, but it might be coming from a method that the try block calls. And in fact, that was the case in the example we just looked at, because our try block called the method quotient, and it was in that area that the exception actually got thrown. So we have try, throw, catch. Here you see the try and the catch explicitly as blocks, and the throw will happen as a result of some statement that executes within the try block. It could be directly in the try block, or it could be a method that gets called from within the try block. And in any case, someplace an exception could occur, and when it does, we abort the rest of the code. In this case, that's the part that says more code to run at the bottom of the try block. That more code to run is only going to get executed when there's no exception. If an exception occurs, it will occur in the middle line of this template where it says a statement or method that may throw an exception. And once that happens, you never do the more code to run. You bail out, you abort the rest of the try block, and you move on to the catch block in that case. In the catch block, again, this is a template, so we're going to have some particular exception type, and we're going to give it a name. In this case, we call it EX. And then within that catch block, we have code that deals with or processes the particular exception that occurred. Here then is a complete overview or summary of what we just talked about. We have a try block, first of all, that has code that gets executed meant to deal with normal circumstances. However, sometimes within that try block, something unusual or exceptional might happen. And when it does, there will be an exception thrown either by a statement directly in the block or as a result of a method call outside the block that throws an exception. If and when an exception actually does get thrown, then the normal course of events is interrupted, and instead we abort the rest of the try block and jump down to the code that's in the catch block, and we execute that. The purpose of the code in the catch block is specifically to handle the particular exception or a particular unusual event that has occurred. This means that we can focus our code for the normal course of event to be in the try block, and any code dealing with the exceptions to the rule is going to be moved out of the try block and into the catch block.